Since linked lists consist of structures that are dynamically allocated, all of the elements are accessed using pointers. So we need to have pointer variables for the first and the last elements, so variables that point to the first element and the last element in the linked list. Usually we have some kind of current pointer as well that points to some element somewhere in the linked list. Now, to create a linked list, the first element is always a special case, as it is created using the first pointer. So there are 4 steps that you have to go through. First of all, dynamically allocate an element in the linked list and have the first pointer point to it. Since right now there's only one element in the linked list, we also have last point to it. Then we need to put values in the data fields, however many data fields we have. And remember that there's always a next pointer somewhere in each of the structures, in each of the elements, and we need to make that last next pointer null. So let's visualize how this works. We have a first pointer, and we have a last pointer, so we need to have variables for those. And our first step is to dynamically allocate a location in memory with all of the fields and a next pointer, and we're going to have first point to this location. It's also the last, so we're going to have last point to it as well. We're going to put values in all of these fields, and since this isn't pointing to anything yet, the last next pointer has the value of null. So that's the first element. Then, after we have the first element, we need to add elements to the end. So to add an element to the end of the linked list, we need to dynamically allocate a new location and assign the address to last arrow next. So instead of having the value null, last arrow next is going to point to the next element in the linked list that we've just dynamically allocated. So there are 4 steps in this process also. We need to dynamically allocate an element, and this time have last arrow next point to it. We're going to move last to point to this new element since it is now the last element in the linked list. We're going to put values in the data fields, and we're going to make the last next pointer null. And then we can execute these 4 statements as many times as we want in any kind of a loop. So we keep repeating the process of dynamically allocating a new element, have last arrow next point to that, move last, put values in the data fields, make the last next pointer null, so that we're always maintaining the integrity of the linked list. Okay, so this is our linked list so far. We only have one element. So now what we're going to do to add another element to the end of the linked list is dynamically allocate a new location large enough for one of these structures. And instead of this next pointer having the value null, what we're going to do is have this next pointer point to the new element. So we dynamically allocate a new location and have last arrow next point to this new location. So now last is not correct. We need to move last so that it points to this element, since it is now the last element. We're going to put values in all of these fields, and we're going to make this next pointer null. So again, we can do that as many times as we want to. Dynamically allocate a new location, have last arrow next point to it, move last, put values in the data fields, and make the next pointer null. As many times as you want in any kind of a loop.